This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
This episode of Know-How is brought to you by CuriosityStream, a subscription streaming service that offers over 1,400 documentaries and nonfiction series from the world's best filmmakers. Get unlimited access starting at just $2.99 a month. And for our audience, the first 2 months are completely free if you sign up at curiositystream.com/twit and use the offer code TWIT. And by DigitalOcean, simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code KNOWHOW in the billing section to get your $10 credit. On today's show,
you'll know how to control your stepper motor.
Welcome to Know-How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Ballecer.
I'm Bryan Burnett.
And for the next 30 to 45 minutes, we're going to be showing you one of the projects that we've been playing with so you can take it home and play with it on your own.
And what was it? The last show we were talking about Arduinos and the difference between server motors and
you know, when you would use
motors.
a server, when you would use a stepper. And what it came down to was there's a right application for each one. In our particular application, where we're trying to build something that eventually will hold a camera, we decided to go with stepper motors.
Right, you have the granular control, but we also learned the math that was involved for spinning it into the 360 degrees and everything.
Right. Yeah, you get, I mean, a servo motor will give you more precise feedback.
Right.
Because it does have a potentiometer built into it, so it can kind of tell you which way it's pointed. But what we're going for is the torque advantage, and stepper motors have great torque advantage at low RPMs.
So what is in like the lunchbox project that we use? What kind of motor is that?
That's just a standard two-phase DC motor.
DC motor,
yeah,
okay.
I mean, that's about as simple as it gets. This, you couldn't just hook up 2 wires to it and watch it spin. Like I said in the last episode, you have to pulse it, which is why when we looked at our example, the little LEDs on the driver board, they were like doing a pattern.
Right.
It's because it's pulsing the 4 phases of the motor to make it turn properly in around itself.
Right. Yeah, and then the binary that you were sending, that we were seeing back on the Arduino was pretty cool too.
Precisely. But last week, our example only did this. It kind of went back and forth. It was an oscillation.
Boring.
A little bit boring. It could be useful for like a security camera that you want to scan an entire area, but
could you do that for a door, though? Could you use that as a door hinge to open and close the door?
You want to really gear it down, because that's a lot of torque.
Yeah, that's true. Because we were basing that off of the chicken coop project that someone had asked us.
Right, precisely. But what we want to do today is we want to take that project and then show people how they could create a frame that could carry things, and then also what kind of programming do they have to do in order to actually control it? Not just let it go off on its own tangent and follow a loop, but take input from its user so that you can point it where it needs to be pointed.
Okay, cool. Yeah. Well, let's get into it.
Let's get into it. The first thing we want to do is we want to go over the parts again, because I know there's going to be people who did not watch the last episode of Know-How, actually the last Thursday's
Who would miss an episode of Know-How?
You know, people get busy, man. You know, I'm not going to judge. You know, sometimes podcasts stack up in your list and they have to get deleted off the bottom.
Yeah, that's true. Okay, let's go over it then.
All right, so the first thing we're going to need is we're going to need stepper motors. Now, you can get some really nice NEMA certified stepper motors. Those are like the ones that are used in CNC milling machines. And eventually we're going to be using those because we're going to need a bit more torque, a bit more power. But for the purpose of this experiment, we're using these super cheap, what are these? These are the 2.8BYJ motors.
And those are off of eBay? Yeah,
these are off of eBay.
$3.
I mean, less. It's $2, and that comes with the driver board.
Yeah.
So obviously this is not super high quality. This is not something that's going to be able to turn a whole lot of weight, but it is geared down pretty well. It has 4,096 steps that have been geared down via 64 times by an internal reduction gear. So it gives us a decent amount of torque at a very low price, and this is probably the best one to actually learn how to manipulate stepper motors on.
Right. I mean, why would you want to spend more money if you then realize that a stepper motor isn't what you wanted to use in the beginning?
Precisely, precisely. And what this will do is this will give you the ability to screw around without worrying about damaging a lot of very expensive equipment. In fact, I bought 10 of these because why not? I mean, I just have them in my kit.
I mean, if we're anything, we're fiscally responsible.
Right.
Because we don't have any money.
Yeah, of course. The other thing that we're going to want to do is we're going to want to get a dedicated power source for the stepper motors, because eventually I'm going to be running 2 or 3 of these. I can't do that off of an Arduino. In fact, I could run one off of an Arduino, kind of. The problem is when it hits like resistance, so when it has to torque up, it will draw exponentially more power, and that would actually blow out the Arduino. So what we want to do is we want to give our project the ability to draw 5 volts for the Arduino and 5 volts for the stepper motor.
Right, so like separate lines then.
Precisely. Now in this particular example, I'm going to draw the Arduino's power from the USB port of my computer, but for the stepper motors, I'm using one of these. This is, if you go to the side shot here, this is a simple 5 volt UBEC, Universal Battery Eliminator Circuit. You see this a lot in RC cars, but I've been using them for Arduino and Raspberry Pi projects because it's a very clean 5 volts, and this will take anything from, I think, 5 volts all the way up to 30 volts and convert it down into that 5 volts that I need.
Okay.
Yeah. So I'll need some way to supply power to my stepper motors. I've chosen to do this. You're also going to need jumpers. You can do it without jumpers just by having wire and soldering wires, but we kind of want to have this temporary because we want to mock it up.
You mean the jumpers for the breadboard in Arduino?
Right, and they just look like this. So this is what a jumper looks like. I've got pins on one side, I've got a socket on the other. This will allow me to easily connect the driver board from the stepper motor to my Arduino without having to actually solder anything in or sort of, bodge together some wires.
Right, and then once you have completed your project, you could probably go back and solder those wires, right?
Precisely, yeah. And that's I mean, this is the prototype. In the prototype stage, you make it so that everything can be changed, because you don't want to have to desolder every time you make a little teeny tiny change, right?
I think we've all learned from that experience where you solder something once and then you realize you have to go back and unsolder it. Yeah.
And remember, we actually talked about this when we did the steampunk goggles project, because the first step was to mock everything up on this table, and it was all breadboards and jumper cables. And then once we had the design and we knew it worked, then we did the hard soldering to put the goggles together.
Exactly.
All right. The other thing you're going to need, obviously, since this is an Arduino project, is you're going to need an Arduino. And again, I'm using this. You don't have to. Some people asked after the last episode if they could do the same project with an Arduino Nano, and absolutely, positively, 100% you can. In fact, I've got the programming that we did last week loaded up on this little teeny tiny one. So as long as it's got an Atmel chipset in it, and like a 328, you've got more than enough memory to drive the logic for the stepper.
Now, the reason that you would want to use an Arduino for this project rather than, because could you use a Raspberry Pi for this?
You could use a Raspberry Pi. You have to remember, I get this a lot. Could I do this project with a Raspberry Pi?
Right.
You could, and actually that offers you a lot of options, because if it's running a Raspberry Pi, you have an Ethernet port.
Right.
You can hook up Wi-Fi and Bluetooth really easily. I'm not big on using Raspberry Pi for embedded projects because Raspberry Pi still has a file system in it.
Right.
So
if the SD card gets turned off improperly or something like that, it could corrupt the system.
Precisely, and it has a long boot time and it has a long shutdown time. And if you disrupt power and then connect it, there's no guarantee that it's going to come back up the next time, because you may have corrupted the SD card.
Right.
An Arduino
is a microcontroller.
Yeah, you can power cycle it all you want.
Right.
And as soon as you apply power, it takes, 2 seconds and it's back up.
Okay.
So yeah, that's why I'm using it. All right, so those are our parts. The next thing we need to look at is we need to look at the 3D parts that we're going to offer. Now, if you don't have access to a 3D printer, you can still do most of this project. You would just have to find a way to support the motors. But if you do have a 3D printer or access to a 3D printer, this is where it gets kind of fun. Alex, if you go ahead and go to input 11, I didn't want to have to create this project entirely from scratch. So what I did was I went to Thingiverse and I looked for a stepper motor project for the 28B, 28YB, whatever it is.
Oh, you searched that actual motor and it came up with stuff?
It is so popular that there are already pieces that are being designed for it. And then I decided to change it. So this right here, this was actually a piece that was created for this project by somebody else.
Looks like a GoPro mount.
It is a GoPro mount. I didn't like it though, because if you'll notice, this area, that's the part that actually mounts onto the stepper motor. It was a little...
Too long?
I didn't really like the way it looked. Yeah, it was too high up. It was actually too skinny. If I was going to put a lot of weight on that, I was afraid it would just snap. So what I did was I went ahead and I chopped off this part.
By creating the void area below it?
Right, by creating the void area, and then I took the piece that I chopped up and I added it to something like this. So this is something I did a similar way with another piece that I also got off the Thingiverse project. I created my own custom base that would allow me to lock this onto the collar for the stepper motor.
Oh, okay.
Let me show you what that actually looks like in real life. Okay, so if you go to the side view, Alex, this is the piece that I created, and I don't know if you could digitally zoom on that. You might have to ME that a little bit. What I did is I've created 3 chambers on the bottom of anything that's going to attach to a stepper motor. And in the 2 chambers on the side, I just put a standard M3, that's a metric, bolt or nut. And then I put these holes on the side so I can put an M3 bolt through it, and it will squeeze the shaft.
Okay.
Right, so the shaft goes in the middle. That's where the stepper motor shaft goes, if you'll notice here. So that just goes down like that. And then I can tighten these screws, and those screws will tighten up against the nuts inside, and then they'll press on that shaft and they'll hold it nice and tight.
Yeah, that looks perfect.
Yeah, I see the laughter.
No, stop. Totally being mature about this.
Being very,
Continue.
very mature. Okay. So, and that's why I decided I wanted a thicker part. I didn't like that little skinny part because I didn't like the idea of
clamping down.
Clamping down. And in fact, the original design, it didn't have an insert for the nut. So you were just using the resistance of the plastic.
Yeah, and that's not a good idea.
Yeah, well, that's a really good way because it'll just strip. The bolt will pull out, and it'll probably pull out at the worst possible moment when you're actually supporting weight.
Okay, so you've made a little sleeve that you can then clamp down onto the stepper motor.
Right. So
Nice.
when you do it properly, I'm going to just use this mock-up stepper motor here. When you do it properly, what you want to do is you want to tighten down one side and then tighten down the other. You don't want to tighten down too much on one side because what will happen is you'll actually push it through the center.
Yeah.
And just kind of gauge where each screw is. If you're using the same length screw,
Just hand tighten.
yeah, they should be just about in the same place when you're done with the process. And then, so that's nice and tight.
Nice.
I can actually hang that upside down. That will hold on to the
That,
stepper
yeah,
motor.
okay, good idea. That's awesome.
Yeah, so and this is actually something you want to do with your 3D design because it's very easy to be so convinced by the strength of the material that you're like, yeah, I'll just put a screw through there and the plastic will hold it.
Right.
Always think about what you could do to reinforce it. And if I can make the collar a bit more snug, a bit more solid, I'll do it every time.
Or avoid using hot glue or something like that.
Yeah, do that. All right, so the other pieces that I want to show you, this is the other important piece, is this. So this is the actual tray that I've created for this project. As you see, it gives me these 2 areas. This is exactly the right size for the driver boards that I've created.
2 driver boards?
Right, because eventually I'm going to control 2 motors with this.
Right.
This is where I would put the UBEC. So the power supply actually goes in here. And then this is where the Arduino goes. So I'd be using an Arduino Nano.
Yeah, I was going to say, that's not big enough for a regular Arduino.
No, right. But again, it controls it just fine. So I went ahead and I created this design. Again, these are going to be available for you. There's a link in the show notes. You can download this. You don't have to create them on your own. And then I wanted this to mate up with the shelf that I got off of Thingiverse. So what I did was I actually just inverted the shelf, made the shelf a hole. See, so from a solid to an empty, and then I pushed that through the top of the tray here.
Right.
So it gave me exact mounting points where the shelf is. Now let me show you what that actually looks like. So Alex, if you go to the side view here, this is what the shelf looks like. That's straight off of Thingiverse. So that design has not been changed whatsoever. But because I put that emptiness into the shelf here, it allows me to do this. So that fits nice and
voila.
snug. Yeah.
And so then this allows you to pull the plate off and when you need to and stuff, instead of just trying to print. I guess you couldn't print this all as one piece because then you'd have to have support to do
well,
this
because you need to
plate.
get the motor in there somehow.
Right.
And the motor wouldn't fit if you couldn't pull this part off. You have to be able to take this off, install the motor, and then put it down.
Right. And when you print, this is how it's going to print.
Right, right.
Cool.
So those are all the pieces that you're going to get. If you download the file, you're going to get all the STLs for all of these pieces, and you can just take them and work with them as you like.
Okay.
And yeah, I'm getting a lot of lifting on my printer right now because the surface, I have to replace it.
Oh, what's like the actual glass piece on?
Yeah, I got all messed up.
So you can't really see it in the camera, but yeah, on the edges it's lifting.
It's lifting a lot.
That's bad.
Yeah, it's not good.
Can't you just use more hairspray?
No. I mean, if the surface is not even,
It's not
no
going to
amount
help.
of hairspray is going to help.
Yeah.
All right, so what we're going to do right now is I want to show you really quickly, I need to create the power source for this, because remember, we said we wanted an independent power source for this Arduino.
Right.
And I'm going to be using this
UBEC.
this Universal Battery Eliminator Circuit. So again, our audience has asked for this. They say every once in a while we want to see what it actually takes to put something like this together. They don't want to see the montage. They want to see the full real deal. So that's exactly what we're going to do. We've got a battery connector. So this will allow me to take it from a standard JST battery.
Right.
And then I've got this UBEC. And this UBEC, wonderfully, has the lead wires on this side. And then on this side, it has a plug that I can actually connect to my driver board, and I'll give it power directly.
Right, isn't it just a standard JST connector or something like that?
Yeah, something like that. And then I'm just going to chop off one side so that it fits.
Oh, okay.
But let me go ahead and let's fire up the iron. I was going to do this beforehand, but then I was like, you know what? I don't want to put Bryan near a hot iron at the top of the show.
Right, right. Let's save it for later when you can burn him 30 minutes into the show.
Legally.
Yeah.
That's what we're looking
Then
at.
it'll be a work hazard.
Yeah. You know, the other thing that people ask me is, should I be using safety glasses while soldering? And actually,
You should, right?
You really should. A lot of us are really bad and we don't, but it's always good practice because anytime you're dealing with anything that has a lot of energy, and a soldering iron has a lot of energy, you're always faced with the possibility that something might crack, something might pop.
Yeah.
And if that stuff pops into your eyes.
Yeah, that could be bad. You don't want liquid metal in your eyes.
No, it's uncomfortable.
And then Smitty also said, don't breathe in the fumes.
But Bryan, they smell so good.
Yeah, if that were only the case, they don't.
Okay, so while that's warming up, what we're going to do is we're going to go ahead and strip some wires. We need to have a little bit of a lead so that we can go ahead and tie them together.
Right. Give yourself some space.
Yeah, I've already stripped the leads on the power connector, so now I'm just going to strip the leads on the UBEC.
I mean, this is pretty brave of you to do live.
Or I just cut through it. Okay, don't tell Smitty about that.
Start over.
Anytime I mess up, it's like Smitty's the guy I'm like, oh, he's gonna make fun of me, man.
Without fail, doing live demos is the most nerve-wracking and mistake-ridden thing we ever do.
Well, I mean, naturally.
Yeah, that's just the nature of the beast, I guess. But
oh, by the way, congratulations on your new job. I think we can tell people that's public now, right?
I guess so.
Yeah. So. Bryan is
different.
now going to be our field producer, so he'll be out with me in the field.
That basically just means instead of walking around with you, I just go and find other things.
Yes,
right?
but as the field producer, now you tell me what to do.
Oh, well, you shouldn't have told me that.
Well, I mean, I don't have to listen.
Well, that's
you
okay.
tell me
so
what
it's
to
no
do.
different than how we've
It's pretty much
ever
like
done.
that. It's like,
yeah,
it's like
normal.
It's like,
Yeah.
All right, so the other thing we want to do is we're going to need some heat shrink and a heat source. Get a heat gun. You really shouldn't be using a torch.
a blowtorch?
You really shouldn't be using a torch, but it's what I have. It's what I'm going to use.
Do as we say, not as we drop.
You probably shouldn't drop that either because it's filled with butane.
Do I need to get safety goggles?
I'm just saying that we've got a couple of OSHA hazards on this desk right now.
As your new field producer, I say we should not hurt
We're not
me.
in the field, man. Sorry.
Oh, man.
I'd love to listen to you right now, but I can't. It's union rules. All right, so I need some heat shrink so that I can protect this after I've soldered them together.
Okay.
Let me repeat this, and it's going to sound silly that I'm repeating it, but everyone who's ever done any sort of electronics is going to know this.
Solder once, measure.
Put the heat
never.
shrink tubing on before you solder.
Yeah, oh yeah, I've done that a few times.
It sounds really stupid to say it, but everyone who's done this for a while, you've done that.
Yeah.
You've done it, where you've soldered something together and then you remember to put the heat shrink tubing on.
And what has happened to me too is I get like this beautiful soldering job that the best soldering job I've ever done, and then
Guaranteed
realize
you have to rip it up.
and then I have to cut it off, and then when I redo it with the heat shrink, it's like crummy.
Well, because you're upset now.
Right,
You're,
I'm
you're
angry.
like, oh man, I wasted all that time. Grr, arg.
Never solder angry. That's the tip for today.
Actually, I prefer to solder angry.
Well, and that's why yours come out crummy.
Okay, so what I'm going to do is I'm just going to go ahead and do a quick twist on the wires here so that I can get a nice mating between them. These are actually pre-tinned, the edges. So that's really the only thing I worried about.
Okay.
All right, so I'm going to go ahead and put this into my helping hand so it will hold it at the right position.
Twisted the little wires around each other.
Yeah.
Good, good.
Yeah. Let's see. Wait, where is that? Can you go to the side and how close can you get to that? Oh.
Oh.
Here we go.
Oh, look at that.
Come on. There we go. All right.
This is live soldering,
This
folks.
is live soldering, folks.
You're not going to get this anywhere
This is so
else.
risky.
You don't see this on any other
Bryan
podcast.
could be killed at any time. Me?
My life is genuinely in danger every time I step onto this set. Yeah.
And you know what? We appreciate that. Thank you. So a little bit of solder on the tip of my iron. It sort of gets things going. Also cleans off all the crud that's accumulated. Remember, whenever you're soldering this, and you know, it's always good to repeat the beginner tips.
Right.
You're not heating up the solder. You're heating up the wire.
Right.
You want the wire to be able to carry the solder.
Because then the solder will flow over the wire and make a better connection, right?
Precisely. But if you're having trouble making that happen, what you can do is you could put a little dab of solder onto the tip of the iron, and it acts like a heat bridge that will conduct the heat back into whatever you're trying to solder. So
if
that's
you're having
one side.
to melt the solder on the tip and then put that on the wire, that probably means you need a new tip, though.
Right. Something else, a lot of you are going to run into this. So I've got two different types of wire here. This is silicone. So this is nice. This will handle basically any heat that I could throw at it. This is just polyvinyl chlorate. Which means
can you tell the difference?
You can just feel it.
Okay.
You feel sort of the rubbery texture here. You feel the plastic texture here.
Ah.
If you heat up PVC too much, it just burns and melts. So you want to do this quickly. Yeah. Or if you're gonna have an application where you're not gonna be able to do it quickly, you want to make sure that you're using silicone wire all around.
Okay.
Yeah. All right. So I'm gonna go and twist together the second set. Again, this is not the best soldering job I will ever have done. This is actually pretty bad. But you know what?
Right.
Smitty's
Gets the job done.
Smitty's not watching, so it's okay.
That's right.
All right, there we go.
Easy.
Same thing. Little dab of solder onto the iron. And then heat up the wire. And once the wire is hot enough, to let the solder flow.
Oh, yeah.
Let the heat flow within you.
Feel the solder surge.
Feel the burn. All right,
Looks good.
Okay, solder iron off.
All right.
Let me put that off to the side so that it just burns air.
Right.
All right.
Put it very near me.
So what we've got now is we've got very simple joint. I'm going to go ahead and run the heat shrink tubing back over that.
Look at that. You even got it color coded.
I did, I know, right? Wow, I actually did it right this time. And then again, you really, 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 really should have a heat gun for this and not do it this way, but we're bad people here on Know How. If you are going to use a torch, move it quickly. You don't want to burn the tubing. You just want to heat it to the point where it shrinks.
Yep. This obviously isn't the first time you've used the blowtorch for that.
And even though you really shouldn't. Seriously, folks, don't use a blowtorch. I'm doing it because I'm lazy and I don't want to buy a heat gun, but don't do it.
It's not like we have one in the basement.
No, it's not. Okay, so that is our completed UBEC. So let's go ahead and hook up our kit together so that we know what parts are going to go where. So the first thing we're going to do is we're going to install this motor into this base. And again, metric 3 bolts are what you're going to want with this design because it will fit just through the shelf that I've designed.
Okay.
Okay. And once you put those on, you'll get something that looks like this. So this is the motor in that shelf. It's been mounted on either end, and this shaft has been centered into the middle of the shelf so that I get that, because I want it kind of centered so I know where to put my weight.
Okay. That looks good.
So this goes onto this base? Yeah, why not? I'll put it on I'll put it onto this base. We're going to put it onto this base, like so. If you want to get this wiring out of the way, you can actually wrap it around the motor inside.
Oh, to tidy it up.
Yeah, but I'm not really worried about tidying right now, so I'm just going to do this. I've also designed the shelf and the base plate so that you can use long metric 3 screws to secure it. So you just put these right through the bottom along with a washer. Like so. and then you just tighten them up with a screwdriver until they come up through the top. I could have made it so looser so that you could just push it right through, but I kind of wanted a little bit of tension.
A little resistance.
Just a little bit of resistance. It also means that the bolts won't vibrate free, because stepper motors do tend to create a lot of vibration, and if you haven't locked down your nuts, they'll just come right off.
Okay.
Okay. So I'm just going to do one, but this has been designed to take longer screws in all 4 of these.
Right, to really secure it down, yeah.
Right. So but one will hold it for now.
Okay.
Okay. So I've got my stepper motor inside the shelf. There we go. And I've gone ahead and connected my stepper motor to the driver board. Now I need to connect the driver board to the Arduino.
Right.
And the way I'm going to do that is I'm going to take this, and I'm just going to remember that purple is my first color, and it's going to connect to IN1. Again, just watch last week's episode, and we'll do the close-ups of what those look like.
1, 2, 3, and 4.
And 1, 2, 3, and 4. So I'm going to do it like that.
Also, it looks like there's extra holes for other pins.
Yeah,
So-
I mean, you can. This driver board can be modified.
Oh, okay.
Okay, but my IN1 is going to be purple. My IN4 is going to be black. So I have to remember that. So it's purple, gray, white, and black.
Right. And then,
Now on the other side, I need to connect these to 4 digital pins on the Arduino. I can't remember what I did in my programming, but I'm going to assume I used digital 4, 5, 6, and 7. So IN1 will be connected to 4, IN2 connected to 5, etc., etc.
I mean, I guess it doesn't really matter as long as you have it in the right order, because then we can change the number in the programming.
Precisely, exactly. And actually, very good point. Yeah, all that matters right now is order, because I can always redo my programming. Now, why am I having so much trouble here? There we go. So again, I'm going purple, gray, white, and black. Purple, gray, white, and black. So it's in the right order. Believe it or not, that's it. That's it for connecting to the Arduino. I just need those 4 pins.
Right.
Now I need
Just
to
need
connect power, which off of my my UBAC here that we just created. I'm going to go ahead and put power in.
And like you said earlier, we're doing 2 separate power sources because we don't want to blow out the Arduino.
Right. So this Arduino is going to be powered off the laptop, and this is going to power my stepper motor.
Cool.
Yeah. Now that's it. That's all the physical construction that we're going to do for this. We will add this to the top of that stepper just so that we have something to point. But the rest of it is going to be all programming. I'm going to show people how they can actually take input over the USB device in order to control the stepper precisely.
Cool.
Yeah. Now, before we do that, let's go ahead and take a moment to thank the first sponsor. We have CuriosityStream. Now, CuriosityStream is a different way to get content for geeks. Do you love documentaries? Do you love how-to? Do you love videos that explain the workings of the universe, the Earth, of atomic bonds? That's exactly what CuriosityStream is, and that's exactly who they're aiming for. Now, CuriosityStream is a subscription streaming service that will offer you over 1,400 documentaries and nonfiction series from the world's best filmmakers. You get unlimited access starting at just $2.99 a month, or for our audience, the first 2 months are completely free if you sign up at curiositystream.com/twit and use the offer code TWIT. Now, CuriosityStream is the world's first ad-free nonfiction streaming service. It was founded by John Hendricks, who was the founder of Discovery Communications, all that programming that you used to love. It's available in 196 countries worldwide. It's available on many platforms, including the web app, Roku, Android, iOS, Chromecast, Amazon Fire, Amazon Kindle, and Apple TV. In other words, no matter where you get curious, you're going to find a way to satisfy that curiosity. They have over 50 plus hours of 4K content, beautiful content, which they've just launched. It's one of the largest 4K libraries on the internet. And really, there is no way to look at a documentary about the Big Bang or about the formation of suns unless it's in 4K. Their library includes Stephen Hawking's universe, Next World featuring Michio, the human face of big data, the road to the singularity, all these topics that are hot and heavy with the geeks. CuriosityStream will offer you a glimpse into the minds of the world's most foremost experts. They've got monthly and annual plans available, and their plans start at just $2.99 a month, less than a cup of coffee or the cost of one title on a competing on-demand platform. Folks, if you are a geek, if you're a nerd, if your mind hungers for knowledge, give it what it wants at CuriosityStream. Check out curiositystream.com/twit. That's curiositystream.com/twit and use the promo code TWIT during sign-up to get unlimited access to the world's top documentaries and nonfiction series completely free for the first 60 days. That's 2 entire months free of one of the largest 4K libraries around. Just go to curiositystream.com/twit and use the offer code TWIT at sign-up. And we thank CuriosityStream for their support of Know-How.
So I've had to bring up that website for other shows, and I've gotten lost watching the Age of Hubble was one of the videos.
It is a click sprawl place. You just kind of go, oh, wait, what? Oh, let me see that.
Like, ooh, stars.
I love it. Hey. Now, when we come back, we're going to show you the programming that actually goes into making this stepper motor a useful tool. But before that, we had a special visitor.
Yeah, speaking of useful tools.
Yeah, speaking of very useful tools, we had a visitor, a longtime member of the Twit Army of Chat Room, who came into the studio and wanted to show off something that he was creating. He is Senior Science. He is the man of the hour. Ladies and gentlemen, we bring you Tensor Guy. I'm here in the bowels of Twit TV studios, and I'm sitting next to a man who is going to explain what you could do with your latest and greatest maker product. He is Senior Science. He is Jaime. We know him as Tensor Guy. Thank you very much for coming in.
Oh, a pleasure to be here, Pat.
Now, you've come in not just because you're a fan of Twit, not just because we like you and you're a cool guy, but because you've created something that has actually become a little bit of a sensation. Tell me about this unicorn-looking fella here.
Yeah, well, this is Toots, and it's a unicorn that announces...
That's way to put it.
Yes, with bright colors whenever you get good news.
Now, the interesting thing, though, is how you actually created this.
Yes.
This is not something you bought. This is something you created. So tell us what's inside.
Well, the original inspiration was a friend of mine's daughter who knows I'm a maker, and she wanted a unicorn that farted rainbows. It's like, please, please. And then 3 other little girls said, yeah, I want one too, and so forth and so on. So I made it for her, and they played with it for an hour. I thought it was going to be 5 minutes tops, and then adults started playing with it. So we realized there was something there, but we wanted to make it a little bit more geeky. So we decided to connect it to the internet. So this is an IoT device, and it will, announce whenever you get notifications in different services. This particular one and the higher end version, we have a little bit of a more accessible one, have a Intel Edison system on a chip in there.
Let's talk about that, because I can do this with an Arduino.
Yes.
I could put a Wi-Fi shield and a Bluetooth shield.
Yes.
So I have connectivity to my phone and to the internet. And then we know how to play with WS2812 lights.
Correct.
And essentially you're using a humidifier element, but I could also use, say, like an e-cig element to do the smoke.
Correct.
You chose to go with an Intel Edison.
Right.
Why?
Well, I did exactly that. The original prototype was an Uno with a Wi-Fi shield and a Bluetooth shield, and the stack became very large, very unwieldy. Also, it consumed more power. We wanted to be able to do like we're doing now with battery powered, and some of the production models will actually have battery inside. So the package in the Intel Edison, especially the mini breakout board with a battery charger on board, etc., was very nice and compact. I also like the XDK. I also like it's running Node.js, and we use all the communications. We use WebSockets, and I like the fact that I can do that.
Are you using both Bluetooth and Wi-Fi on the Edison at the same time?
Right. We're doing 2 things. We're using the Wi-Fi mostly for the initial setup, and so at the initial setup you can log into your Twitter account and certain things that don't necessarily need to be on-the-fly authorizations. And then it's producing this website, and you're using that for all your other services, like it has Twitch Alerts integration. We're working on Patreon integration as well, and so that's another thing that the Edison will do. And why we chose to go with it.
There's a big gap between the ability of making something that's cool, and then actually marketing, building, and selling something.
Yes.
And unfortunately, we've seen the collapse of a lot of really well-intentioned Kickstarters and Indiegogos because the people don't understand what it takes to turn something from concept to product. Tell me about that process for you.
This is a This is a product that we built specifically to make a test of our process because we have a very ambitious project that we'll bring to you in the future that we had trouble with.
Right.
So we decided to make a campaign on something easy and something that we all love. And so we did this. Actually, we developed Toots and the interface and the campaign in about 45 days. We came up with the concept first, and then the art, and then the idea was to fit everything within the size, the minimum size. Very important for makers out there that want to turn it into a campaign is that we are inclined to think that once you have a beautiful product, you're done. But no, that's the beginning. There's a lot of promotion. There's a lot of communication. You have to go to all your friends, make sure that they share it, and it's a little bit embarrassing. But if you have a good product, they will do it joyfully. But also, you have to make sure that what you're building can be replicated.
Yeah, and so many of these projects fail at that stage, the scaling up stage. Because here, this is nice. We've got a 3D printed case.
Yep.
You've got these sort of custom assembled electronics.
Right.
But if you're going to turn it into a product, you have to think, okay, I can't 3D print every single one of these cases, so we're going to do injection molding.
Right.
If I'm going to do injection molding, it means I have to go through the steps to make sure that they're going to make it exactly the way I want it. That's going to take time. It's going to take money. Also, these electronics, all those things that I did to sort of bodge together to make it work, can't do that. It's got to be a well-defined process that can be mass assembled. I mean, if you sell 10,000 of these, you're not going to be hand assembling 10,000.
You can't. We have a process where we basically make it work first, very early, and it doesn't look great. It actually, you know, there's some stuff out on the internet. I can let you see it, but there's a process of developing a production unit where you simplify. You try to reduce the components. You want to make it as easily accessible and replicated as possible. That's also one of the reasons why we chose Edison for the higher end, because it was less components, it was less stuff that we had to build. So yeah, you have to make sure that you develop specifically for mass manufacturing, and that's going to mean some compromises. You know, Toots is a very simple box, it's a very simple enclosure, and that's like that for a reason. It's because, you know, we can make that injection molded outer enclosure easily, and the art can be put in quickly. You have to think, I think a good amount that you have to think whenever you make a project like this is that you're going to make 1,000.
Right.
And think in those terms. You know, and think of yourself and your friends actually trying to assemble this, and you know it's going to be trouble. So you have to simplify. You have to make sure you can buy wherever you can, you know, buy pre-made parts and so forth and so on.
Yeah. And that's just one of those things in moving from being a maker to being a producer.
Right.
It's very, very connected, but there's a specific skill set that's involved in turning something into a duplicatable product.
Right. The good news is that you can, and this is a little bit of our philosophy, is that we want to subcontract pieces of them. And we can put them together in a box, or we can have a fulfillment center do it. But you want to be able to cut your project into segments that you can, you know, subcontract or purchase individually. You know, if you do that correctly, I think you have a very good chance of becoming a business at something you love.
Could you please tell the folks where they can find out more information about Toots? I know you've got an Indiegogo going on right now. I'm hoping our audience rushes out and gets themselves one of these so that they can experience the joy of Toots in person. Where can they go? Well,
they can go to Indiegogo and search for Toots, or they can go to tootstheunicorn.com.
Tootstheunicorn.com.
Tootstheunicorn.com will direct you directly to the Indiegogo, and you know, it's fun. There's several levels. We recommend the higher end because it has a higher processor, and your audience will appreciate it. It has more memory, and you know, it's a thing of joy.
It really is. Hey, Padre, Bryan, from the backstage filled with unicorn farts, back to you on the Radio Corner.
That was
It's a
awesome.
unicorn that farts rainbows.
It smells like rainbows in
really
here
does,
now.
right?
Yeah, that is such a cool project. I love that.
And it was nice to meet Tensor Guy finally in the flesh. I mean, I've seen him in the chat room for such a long time. He's a good man. That interview actually went on for another 6 minutes because he
I believe
described
it.
a lot of the different components and the processes that went through the design. It was fun having him here.
No, totally. That is a Indiegogo that I'm gonna go fund immediately.
Just remember, tootstheunicorn.com.
Toots.
It's an Indiegogo campaign. We'll make sure that the links end up in our show notes.
I kind of want to design a corgi one now,
Right?
though. Like
Corgi?
little rainbow farts coming out of a
it
corgi.
would have to be the bubble butt thing.
Oh yeah, the butt shakes.
Right?
All right. Thanks, Tensor Guy. I have an idea for a project now.
Now, this is what Thursdays are all about. Thursday is the maker side of know-how versus the DIY side that we do on Monday. And by the way, we're not the only ones making right now. On the other side of the studio, there's a group of crack engineers, including
Top men, Padre.
Top men.
Top
Who?
men.
Exactly, top
and
men.
women. Yeah,
And, well, they're doing this. Alex, if you go and go over, right now they are assembling a MAME cabinet. And that is our very own Jason Howell and Aaron Newcomb. Aaron's doing a little bit of the programming. Jason, actually, people don't realize Jason he does stuff like this every day. He's always assembling things and taking things apart.
He is.
It's kind of what he does. Yeah. So, folks, that's right. The know-how spirit has caught on. Speaking of the know-how spirit, I think we need to tell our audience about our second sponsor.
Yeah, about building stuff, but having it not be too difficult either.
Exactly, and that's why we love DigitalOcean. Now, DigitalOcean is a different way to think about deploying a server or an app. You don't have to build up the hardware. You don't have to contract with a colo to put your gear into. You don't need to maintain it. Instead, they give you droplets. These are self-contained pieces of software, containers we call them, that allow you to encapsulate your app, your service, your web portfolio, your website, whatever it may be, and run it anywhere on DigitalOcean's infrastructure. Now, DigitalOcean is used by over 600,000 developers, including myself, Aaron Newcomb, and Randall Schwartz. DigitalOcean lets you deploy and configure your droplets via a streamlined control panel or a simple API, and you get to choose your OS: Ubuntu, CentOS, Debian, Fedora, CoreOS, and FreeBSD. You can select from one of the many pre-configured one-click installs like Drupal, Docker, or Node.js to get up and running quickly in case you have that project that just needs to be on the web now. Or, because they give you root access, you can deploy your infrastructure exactly the way you want. It's highly scalable to meet the demands of a rapidly growing application or business. This is the beauty of the container, of the droplet. The ability to take it and run it on a single CPU with maybe a SSD and a little bit of memory, and then expand it to hundreds, thousands, tens of thousands of CPUs across arrays of SSD with all the memory you can think of with the click of a slider. You can also use advanced features like floating IPs for high availability, private networking, and automated deployments via an API. And they've got an extremely active community, which is important to me. When I look at a service that I might base my future projects on, I want to make sure that it's going to be around in a year. I want to make sure that it actually supports its customers. And because DigitalOcean has such a loud, vocal customer base who are always willing to help newbies, it tells me that they don't just use DigitalOcean, they love DigitalOcean. It's so easy to get started. You can deploy an SSD cloud server in as little as 55 seconds. Really, you don't have any reason not to use DigitalOcean, except maybe if you can't pay for it, which is why we're going to do this. They've got incredibly affordable and straightforward pricing with servers that are starting just $5 a month, and there's also hourly pricing available starting at less than a penny per hour. But we're going to make it so that you can get up and running with DigitalOcean for nothing, completely free. Visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code KNOWHOW for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do for you. That's DigitalOcean.com, DigitalOcean.com. And once you sign up, enter the code KNOWHOW in the billing section to get your $10 credit for free. We thank DigitalOcean for their support of know-how. Speaking of programming and projects, we promised these people some code.
Yeah, we've got the hardware out of the way. Now we got to dig into the code.
Let's go ahead and dig. Now, Alex, if you go to the side shot, let me show you what this quick prototype is going to allow me to do. So it's not rotating right now. It's no longer running that loop code that we had from last week that would allow it to just go back and forth. Stop poking the camera, Brian.
Do something.
But what I can do is I have assigned keys on my keyboard. So if I hit A, it starts spinning that way. If I hit D, it starts spinning the other way. And
So
I
you're-
can control like individual steps.
That's cool. You're remote controlling it. Yeah.
Oh, look at me. Ah, I am a robot. I'm a fire-breathing robot.
Yeah, if only we could shoot rainbows out of it.
I know.
We'll do that later.
I'm working on that.
Yeah,
I'm working
yeah,
on that.
yeah.
And believe it or not, the code to do something like that is not a whole lot more than what we did last week.
Do you have to add any extra libraries or anything?
No extra libraries. It's all built into Arduino. And actually, let me show you the code right now. We're not going to get through all of this, but I'm going to show you enough that you can start poking around. And I'm actually in the show notes going to give you the complete code to do exactly what I just showed you. So, Alex, go ahead and go to my screen. This is the first part. This is the lesson 1 for our Arduino project. What we need to do is we need to make the Arduino recognize input coming in over the serial port.
Right.
Because that's how it's connected. It's connected to my computer via USB, which provides power to the Arduino and a two-way communications lane via serial.
Oh, okay.
So here's what we're going to do. In the setup, look at this. First, we've got incoming byte equals 0. That's just a variable that will hold the data that comes in over the serial port.
Okay.
Yeah, that's all that is. That's very simple. Now look at the setup. This is crazy easy. There's just one line. I'm opening up the serial console and setting it to 9600 baud, 9600 bits per second.
Okay.
Right?
Okay.
Again, not bad. So what I've got is I've now created a place to store the values I get over the serial port, and now I've opened the serial port.
I see.
All
Okay.
right. Now look at the loop. What I want is I want the Arduino to do nothing. That's why it's just sitting there. It's doing nothing
until you send it a signal. Yeah.
Precisely. So what I did for that is I created a if statement, and I used a built-in function called serial available. What that will do is it will say if serial available is greater than 0. So in other words, if there is something on the serial port, on that serial line, then do something. Otherwise, just sit. Just let it go by. Just let it go by and again and again and again. So it's going to wait for data to be available on the serial port, and then it's going to read whatever that data is, serial read, into that variable I created up top, incoming byte.
Okay.
Right?
Read the incoming data.
Yeah, and by the way, this is code that was readily available on the internet. This is from the Arduino website. I modified it slightly to fit our purposes.
And added some comments to make
Added some comments to make it a little easier for you to understand what's going on. But then this right down here, this is essentially debugging. I'm saying create a new line, so jump to a new line so the screen doesn't get so jumbled. Then go ahead and print I received, and then repeat what was ever in that byte.
Okay.
Okay, so let me show you what that actually looks like. Let's go ahead and upload this sketch. Stop it. Okay, compiling and uploading and then done. Okay, so what I need to do is I need to open up a serial monitor. So now this is connected to the Arduino, and that Arduino is running the code that I just showed you. So if I type like H and then I send it, via this button here, it says I received 104. And the reason why it says that I received 104 is because it's not actually receiving H, it's receiving the ASCII value. And the ASCII value for that
is
key
104.
is 104. Like, for example, let me do Q. 113. 119. R is 114. T is 116. Y is 121. So every key on the keyboard has a value.
Okay, and then are you going to set that value to move it in a certain direction?
Maybe.
Yeah, okay.
Maybe I'm going to do that. But
See where
first,
you're
what I'm doing is I'm showing them how this is going to work. So that little bit of code, all it did is it waited. So the Arduino sits and waits until data comes down the serial line.
And then it repeats back what it got?
It stores it, and then it repeats back the value it got. But the value it got was not the key, it was the value of the key.
Right.
Does that make sense?
Right, that makes sense. That makes sense.
So when my computer, when this Arduino is listening, it's not receiving H, it's receiving the binary code for 104.
Right.
And it knows that that's H.
Right.
Okay, so let me shut this down, and let me show you some of the additional code that we've added in here. Because we want it to actually do something when it receives the right keystrokes. In this case, I set it for WASD, W-A-S-D. You know, that's like the keys for like moving when you're gaming.
When you're playing FPS or something.
Precisely.
Yeah.
So I want to set W to be up, S will be down, A will be left, and D will be right.
That makes sense. Yeah.
But I've only got one motor, so I'm only going to deal with left and right now.
Okay.
Okay. So let's go through the code. Something was coming down the serial port. It went ahead and stored that value inside of incoming byte.
Right.
And then it printed it back. That's what we just saw, right? Now I needed to do something with that. But I only wanted to do something if I pressed one of the keys that I actually have set for motion.
So A or D?
A or D. And A is 97. And D is 100.
Okay, because yeah, if you hit any other key, it'll be a different number and it won't do anything.
It won't do anything, right. These are the only two conditions. So these are what are called nested if statements. These if statements are nested inside of that top if statement.
Right.
So what I'm asking is, if there's data, and then if that data meets this.
Right. You're parsing it down.
Precisely. So I say if there's data, then go ahead and look at these if statements here. If it's equal to, and that's why it's a double equal, so equal to 97. So if the value inside of incoming byte is equal to 97, then run this.
And so serial print /n and key press A.
Right, so it tells me I pressed A.
Okay.
If the data comes in and it's 100, then I'm going to print key press D.
Okay, and that's just that's what will be repeated out to the little terminal screen?
Precisely. So let's go ahead and run that again. So actually the Arduino's still running, so we just need to reopen the serial monitor. So just to show you, if I hit Q, I just get the ASCII values, right?
No,
but if I hit A, so let me go ahead and put A in there.
It should return the...
There we go. So it hit that second statement. It said, oh, okay, so you hit 97. I have to also tell you that key press A. If I hit D, key press D.
Cool.
Okay. Now, that seems really silly, but it's important because it means that we can trigger certain events when I hit certain keys.
Right, which you want it to go pan left or pan right.
Exactly.
Depending on the key that you
Which
press.
is why we've got this. Let me shut this down. So this is basically the code from last week's episode. This allows me to access my Arduino and the driver. So I'm telling it IN1 is on 4, IN2 is on 5, IN3 is on 6, etc., right? It also has all the same parameters I had last time. How fast do I want it to move?
The number of rotations.
Number of rotations, and this little array that gives me the proper sequence to pulse the motor.
Right.
Okay. So that part is actually just lifted from last week's project.
Right.
But what we've added is the if statement. So same code. It's going to do nothing until it hears something down the serial port. When it hears something down the serial port, it will take that data and it will put it into incoming byte.
And if that data is the two numbers that you
97 or 100, then do something. But this time I don't want it just to print something on the screen. I actually want it to move the motor.
Right. So there must be a command for that.
Look at that. That's from last week. That's the code from last week for moving something counterclockwise. So if I hit the A key, it's going to loop the function CCW counterclockwise 3 times. Or actually, yeah, 3 times. So 0, 1, and 2.
Okay.
Okay, and what that is that's the function down below.
I see.
Here.
I see.
That moves the motor. So again, I lifted this straight. I did not change this at all from last week's. All I'm saying is last week, it had a loop that would just run clockwise, counterclockwise, clockwise, and it would just keep doing that forever. This week, what I've done is I've used the same functions, but I'm saying only trigger the clockwise or the counterclockwise function when I hit the corresponding key.
Right.
All right, so let me go ahead and upload this. Okay. Boom, 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 boom. It's going to come out and upload it. All right. Now, if I can go ahead and open up a serial monitor. And Alex, can you do the serial monitor and...
yeah, can you squeeze the serial monitor vertically a little bit?
Sure.
So I can see the top of the box and the bottom in the same window and not be too tiny.
Serial monitor does what it wants.
It's like a honey badger.
Squeeze it. Yeah, there we go.
Like that?
A little more.
Okay, like that.
Yeah, that should work.
Ooh, yeah.
All right. So if you put that in a 2-box with, there we go. So if I put A.
I want to bring the bottom of it up a little bit so you can see the command as it comes in.
Yeah. Come on.
No, from the bottom.
Hold on, this is...
Don't you have a mouse?
Actually, that's as small as it wants to get.
Okay.
Yeah. There we go. So A, and it moves it 1 step.
I received 97.
Actually, 3 steps. See how every time I do that, it's going to bump it over? I do D, it goes the other way. But here's a problem. That's kind of annoying if I have to move it 1 step at a time and hit enter every time.
That's very annoying. You
That's
should be
very
able to just hold down the button and have it turn that direction.
Precisely. Which is why I'm actually not going to use the built-in serial monitor. What I'm going to do is I'm going to use a program downloaded for free off the internet called TerraTerm. It's Terra Terminal. Actually, yeah, there we go. So I'm going to tell it to go to the serial port on COM5.
Uh-huh.
Okay, Alex, if you go to the 2-shot again, I'll set this for the right height.
Just leave it there. That's good.
Okay, so it will do the same thing as before. So if I put Q, but notice how I don't have to hit enter.
That's
immediately when I press a key, it's triggering,
up.
right? But if I hit A, there we go.
There you go.
But I could also hold it down.
Boop. Nice. And is that just because in this program you can auto set, it just does the return after you hit a key?
Exactly. After every character, it sends.
Okay.
In the other one, the built-in monitor, it's
can't do
waiting
that.
to send until you tell it to send.
Right. See, that's awesome.
And again, this is inside. If you download the code for this week's episode, TerraTerm's going to be inside of there.
Cool.
There you go, folks. Now, this is incredibly rudimentary. This is just in 2 directions, and it's not all that smooth. So what we're going to do for next week is I'm actually going to add the second dimension. We've got 1 stepper motor here. We need another stepper motor so that we can control both the pan
And then
and
the
the
tilt.
tilt.
Very
And we're
nice.
going to do it with this GoPro camera.
Awesome.
Yeah. This is actually not that hard, folks. The complete part list of this would be about $15, I think.
Yeah.
It's $2 for $4 for 2 motors. You're talking another $2 for the BEC. Then you've got the Arduino, which you can get for $1 something.
Right.
And then miscellaneous pieces and parts will add to about $5 or so. So for less than $15, you could have yourself a working pan, tilt, zoom mount.
No, that's really cool. I think for me, I would want to do a time lapse where it tracks
Right.
something across the sky. You know, and you could program it to follow if you know where it's going to be going.
Well, that's why we're showing them this code, because the code, it just sets a condition on when it runs either the clockwise or the counterclockwise function. Well, that condition could be anything. In this case, it's what I hit on the key, but you could also wire it up to a sensor. You could say, every time you see motion, turn towards the motion.
Right, or you could set it up on a clock.
You
And
could-
every
exactly.
time, at this time, move to this position. Yeah.
Right, like follow the sun. This would be actually a very easy way to make a sun tracker.
Yeah, exactly.
Yeah, yeah. Which is probably what we'll do in a future episode. Now, we know that this has been a lot of information, but we're going to make it really, really easy for you to follow along. What we've done is we've created show notes, which will go up as soon as this show publishes. Brian, where are they going to find that?
They'll find that at twit.tv/KH, and not only will they find the show notes, but they'll find past episodes. So if you want to follow along with the projects, that's probably where you want to do it. You can also download and subscribe.
Yeah, yeah. And also, if you want to follow along, you need to be part of our Google Plus group. We've got over 10,000 members, know-it-alls we call them, who are of all experience ranges.
All ages.
All ages, all
Yeah,
colors,
all experience
all
levels.
experiences.
Yeah.
If you have a project you want to show us, you can go there. If you have a project that you need help with, you can go there. If you just want to be an expert and show us the kind of things that you've done and you want to show off the things that you've created, again, very easy. Just go to Google Plus and look for the Know-How group and join.
Yep, but that's not the only place you can find us. You can find me on Twitter at @cranky_hippo if you want to see a behind-the-scenes look at what we're doing or upcoming projects.
And you can find me at twitter.com/PadreSJ. You can also find out what I'm doing when I'm not doing Know-How, which actually is never, because I'm always tinkering with something in my lab. This is actually funny. This is why we tell people to join the YouTube channel, youtube.com/knowhow, because I've been toying around with the idea of just broadcasting whatever I'm doing. I'm not going to talk to
projects,
people.
yeah.
Just show you 3 hours of me doing stupid things in my
Stuff
lab.
that we can't really put on the show.
Yeah.
Or Alex won't let us because of time constraints.
Yeah, yeah. Speaking of Alex, don't forget that you can follow our fantastic director. Is his name Alex?
It's Alex, but
Grumple.
it's Grumple.
Alex Grumple, ANELF3.
Excuse me, Padre. It's pronounced Gumpel.
No, I would have known that. I would have remembered that.
Whatever you say, Al.
Sure, yeah. Until next time, I'm Father Robert Ballecer.
I'm Bryan Burnett.
And now that you know how,
Go build it.